Hello everyone, this is the example 2 of shear force diagram and bending moment diagram. In this video I am going to show you how to draw shear force and bending moment diagram for this beam. So we are going to separate this beam into two parts. So we usually mark dash line through point loads and supports. So you can see uh, there are 3 points A, C and B. At A there is a point load of 5 Newton. So this is the distance between A and C, it's 2 meters, and this is a pin support and this is a roller support. Distance between these supports are 10 meters. And I am going to draw shear force diagram on this axis and bending moment diagram on this axis. Our first thing is drawing free body diagram. So you can see I am going to draw free body diagram in this picture, and drawing free body diagram means we have to draw support reactions on this diagram. So first we look into our supports. At C there is a pin support. So if we have a pin support, we mark two force components which are horizontal force component and vertical force component. So I will mark it here at C. These forces are force components of this pin support Cx and Cy. Then at B there is a roller support. If we have a roller support, we mark one vertical force component. So I marked it as By. So this is the free body diagram of this beam. But we can't just keep this diagram as it is. We have to find these forces, these three forces, Cx, Cy and By. So my next move is finding these three forces. First I consider sum of all horizontal forces. If we look at this diagram, we can see there is only one horizontal force, which is Cx. So that means Cx is equals to 0. Next I am going to take the moment about point C to the counterclockwise direction. So you can see the direction here, I marked it here. So if I take moment about point C, I'll have this By force. So it is plus By because moment due to this By force is counterclockwise direction, and this 10 is distance between this C and B. Then 5 Newton. 5 Newton is this force. So it is plus 5 Newton because moment due to this force also counterclockwise. So I put plus sign here, 5 Newton times 2. 2 is the distance to this force, it is 2 meters. So now I can simplify this. When I simplify this, I can get By equals minus 1 Newton. Next I am going to take the all vertical forces. So I will consider sum of all the vertical forces. So when we consider vertical forces, we have to consider three forces. This 5 Newton force, this Cy and By. So I will write Cy plus By minus 5 Newton because I will consider upward direction and Cx and By are directed to the upward direction, and this 5 Newton force is directed to the downward direction. That's why I put minus sign here. So Cy plus By minus 5 Newton equals 0. In this Cy and By, I know already value of the By, so I can substitute value of By for here. So you can see Cy minus 1 Newton minus 5 Newton equals 0. When I simplify this, I can get Cy equals 6 Newton. So now I know all the support reactions, so I can mark it here. You can see I mark as upward direction this force, but results came, it's -1. That means this force is acted opposite direction. So I marked it as plus Newton, but opposite direction. So this is the complete free body diagram. So as you see, I didn't mark the horizontal force because its value equals to 0 when I find it. Free body diagram is complete. Now I have to draw shear force diagram and bending moment diagram. For that, I consider part by part. That means first I consider this AC segment, then this CB segment. If I consider AC segment, I have to cut through this point. So this is a random point. Then I can regrow it like this. So you can see this is the point load and this is point A, and distance I marked as X. If I mark this point as P, I can write this point as P. This is the point P, and you can see I marked the distance as X, so that means this distance is X. So you can see shear force and moment here. So this is downward force is shear force, and this bending moment. You wonder why these directions are downward and this moment is counterclockwise. So that came from the sign convention. Sign convention is very important. We have to define our sign convention before we calculate or before we draw shear force and bending moment diagram. So this is the sign convention I use. So it says shear force clockwise positive and bending moment sagging positive. That means moment due to shear force we mark should be clockwise, and bending moment we should mark as it generates sagging moment. So as you see, moment due to this V1 force is clockwise direction. If you take the moment about A of this V1 force, this moment go like this. That means it's clockwise direction. And if we consider this moment is this direction. That means if I give a moment of m1 to this piece of beam, it deflects like this. So that is the sagging direction, right? Hogging direction is this direction. So this is sagging direction. That's why I mark like this. I can't mark other direction. So now I have to find this V1 and M1. Those are the graphs of shear force and bending moment diagram. So first I am going to consider sum of all the vertical forces, and keep in mind I consider downward direction. So when I write downward forces, you can see I have to write this 5 Newton force plus V1 because both forces are directed to the downward direction. And when I simplify this, I can get V1 equals -5. So this is the graph of the shear force diagram for this AC segment. And please keep in mind this is the range 0 to 2. This graph vary between 0 to 2. So let's see what is the shape of this graph. So this is a graph paper. So this is our function v1 equals -5. This is like y equals -c. So if I draw this type of line, it comes c is like this, and this is the line. This is a straight line and it's a horizontal straight line. So in our diagram I can draw it like this. So horizontal line, and the value is -5. So I marked it here. So this is the shear force diagram of this AC segment. So next I am going to find the function of M1. So that is the graph of bending moment diagram. So for that I am going to take the moment about point A to the counterclockwise direction. So when I take moment, I have to write m1 plus m1 because the m1 is the same direction which I consider, and minus v1, because moment due to v1 is clockwise direction. I consider counterclockwise direction, therefore I put minus sign here, and v1 times x. X is the distance to this v1 force from point A. Now I know the value of v1. Value of v1 is minus 5. So I substitute here, and now I can simplify this and get m1 equals minus 5x, and the range is same range we considered before, 0 to 2. So let's see what's the type of this graph. This is the graph space, and this is the our function m1 equals minus 5x. It's like y equals minus mx. So in these type of graphs, it's like this, and this is the slope of the this straight line, it is m. So in our case, this slope should be 5. So you can see minus 5 here. Slope is minus 5 of our actual graph. So next I am going to draw bending moment diagram. Before that, I have to find the starting point and ending point. For that, I am going to substitute x equals 0 to this function. So when x equals 0, it's simple. You can see m1 equals 0, and also you can see there are no moments in point A. It's a free end, so that means moment is 0. Ending point is this 2, so therefore I substitute x equals 2 to this function. So when x equals 2, m1 equals minus 5 times 2, and it comes m1 equals minus 10. So now I know starting point and ending point, and also I know shape of the graph. Now I can draw the bending moment diagram for this AC segment. So this is the bending moment diagram for AC segment, and value of this point is minus 10. So that's how I draw bending moment diagram for AC segment. Next, I am going to draw shear force diagram and bending moment diagram for this CB segment. When I consider CB segment, I have to cut this beam like this. So here I mark x from point C, and I marked it as x. So if this point is 0 or O, I can mark O at this point. So you can see this is the point load 5 Newton, and at C there is a support reaction of 6 Newton, and point 6 to this distance is x. I marked it here. So if I have to consider this point C, I have to substitute x equals 0. If I have to consider point B, I have to substitute x equals 10. So how it works, right? So same as before, I mark V2 and M2. So V2 is the shear force, and it is clockwise moment, and M2 is the bending moment, so it is the sagging moment. As I found before, here also I am going to follow the same procedure, and first I consider sum of all the vertical forces. So if I consider vertical forces, I have to write plus 6 Newton, that is this force, and minus 5 Newton and this force, and it is downward direction, that's why I put minus sign here, and minus V2 also directed to the downward direction. So that's all 3 vertical forces, and it equals to 0. When I simplify this, I can get V2 equals 1 Newton. So this is the shear force diagram of this CB segment. So now I am not going to draw it in a graph, I just draw it here. And this is the range is 0 to 10. So range I got from this distance. So I consider this CB segment. So I mark x from here. That means this range is 0 to 10. X should be larger than 0 and less than 10. So I can draw shear force diagram here, and it's like y equals c. So as you know, it is a horizontal line like this, and its value is 1. You can see this distance is higher than this distance, because this value is 5, this value is 1. If we consider numerical values, this distance should be large compared to this distance, right? So this is the shear force diagram of CB part. Next, I am going to find bending moment diagram. So for that I am going to take moment about point A. If I take moments about this point A, I have to consider this 6 Newton, this V2 and this M2. So I will write plus M2 because that's the same direction we consider, and minus V2 because if we consider this V2 force, if we take moment about A of this V2 force, it is clockwise direction, but I consider counterclockwise direction, therefore I put minus sign here. And this is a force V2, and distance to A to this V2 force is 2 plus x. That's why I wrote x plus 2 here. And plus 6, moment due to this force is counterclockwise direction, there 6 is the force and 2 is the distance between A and this 6 Newton force. So that's why I wrote 2 here. So now I can simplify this, and here I substitute 1 as V2 because previous step I found V2 equals 1. So therefore I substitute 1 here. Now I can further simplify this and get M2 equals x minus 10, and here also range 0 to 10. So this is like y equals mx minus c. Now I can draw bending moment diagram for this CB part. For that I have to find the starting point and ending point. So now I am going to find value of M2 when x equals 0 and when x equals 10. So when x equals 0, M2 equals minus 10. So it is obvious that this diagram is starting from this point, since this value is also minus 10. So ending point, for find ending point I have to substitute x equals 10. So when the x equals 10, M2 becomes 0. So this diagram is ending from this point. So this is the final bending moment diagram. So this is the complete shear force and bending moment diagram for this beam.